Well, it's really great to be here today, and my major secret about how to design better is to collaborate with Michael. He and I have had the chance to do a number of projects together. Right now, one of the funnest things we're doing is we're teaching the same intro HCI class, both at Stanford and at UCSD. And teaching is often a really solitary activity for faculty members. And the chance to work together with Michael, where we trade stories every week over video conferencing and improve the materials together, has been super fun. For a long time, I've been really interested in design education. I started out as an artist and designer, and one thing that I didn't notice explicitly, I think, until many years later was the role that the design studio plays in helping to coordinate design learning. And for many of you who have been in a design studio, this is a photograph I took of the Stanford Product Design Loft. You can see how all of the stuff in the room is visible to everybody else. And in contrast with, say, philosophy, where I don't know what somebody else's paper contains or what feedback they got on it, in a design studio, it's really easy for me to see what are other people working on, when do they change directions, what feedback did they get, what skills do they have. All of this social coordination happens essentially automatically because of the physical layout of the space. And this wasn't entirely by accident. The design studio came into being with the founding of the École des Beaux-Arts in Paris in 1819, and it's endured for nearly 200 years, I think, because of many of these properties. Interestingly, I think that computer science has had this also in many ways. When I was an undergraduate, there was one room where you could do all of your computing work on Unix machines, and it meant that everybody from freshmen through graduate students was shoulder to shoulder in the same room. And so when you were new, you could turn to the person next to you and get advice so you could learn more quickly. They learned better by being able to help you, and you got a sense of what the breadth and depth of the field was, and it created lots of relationships for many years. I'm still close friends with many people that I first met in the lab here. And my friend Carrie Karahilios tells me that when MIT got rid of their Athena cluster, their equivalent of this room, the social fabric of the program really dropped off. I taught for 9 years here at Stanford, and the first design class that I taught was with Bill Verplank and Wendy Ju and these students here. And we had a lot of fun teaching together. It worked really well. And on the whole, the evaluations were strong, except for one aspect, which is the question that asked students, how fair is the grading, was in the 13th percentile. And when I thought about it, that made perfect sense. Bill and Wendy and I all have a studio design background, and we were teaching it like a studio class, which makes perfect sense in an art or design school. But in an engineering program, a lot of the feedback seemed random, probably truthfully because it was under-anchored. And I've spent a lot of time since then trying to convey how, design isn't quite as formulaic as something where there's a precise right or wrong answer, but there is a different, that doesn't mean that all designs are equally good or fit situations equally well. And over the years, I got really interested in self-assessment. And if you are, this is a great book by David Bowd that I recommend. And I'll give you the point of my talk right now because I think that that way, if you can interrupt with any questions that you want, and we don't need to get to any of the rest of the slides. If we don't, that's fine. The one major takeaway from the talk, it's from the Department of Obvious, and yet still really under-acknowledged, that peer learning approaches work well when they're integrated well into classes, and that an important way to do this is to have scaffolding structure, which is really critical and often overlooked. So our first experience teaching design, we didn't give students enough structure for them to be able to understand the comments that we were providing. And I'll give you a number of examples of this. So that we're on the same page, here's the class that Michael and I teach. Each week, students do projects, then they share them in studio, and for evaluation, both the teaching staff and the students use these rubrics for providing feedback and assessing their own work. And designing good rubrics is really hard. When you design them at first, they either tend to be extremely vague or absurdly specific, so it feels Mickey Mouse. and it just takes a bunch of iterations to get one right. Here is one of our current rubrics. And what we found is that we have the staff assessment and we have students self-assess each other. And part of my motivation for self-assessment is I had the hypothesis that if students assessed their own work, if they looked at their own work through an evaluator's lens, especially after seeing a bunch of peers in studio, they would see that as they would be able to understand for themselves what was strong and weak about their work and where there were opportunities for improvement. And we found that this is in fact the case, that there's a really strong correlation between students' self-assessed work and the staff assessments. Notably, what you see is that high-performing students tend to underrate and low-performing students tend to overrate. To some extent, this is a statistical artifact that's a regression to the mean, but I think it also conveys how one reason that high-performing students perform so highly is they hold high standards for themselves, and the opposite for low-performing students. And I'm going to show a number of examples of using peer assessment to generate grades and scores, which I think is useful, and also you can plot it. But I want to really emphasize that I think the biggest transformation of a lot of peer learning approaches is the value that you get in terms of you learn a lot more in this active way than when there's the sage on the stage who just says 7, 9, 10. And so I think there's a big difference. Also, and I didn't realize this ahead of time, certainly not to the extent that it's true, is in a computer science class where the work that you submit is graded automatically, the teacher's a coach, because the teacher has no role, at least directly, in grading any of the assignments. The TAs have no role in grading any of the assignments. So the only thing they can do, their only role, is to help you. And that's transparent both to the teachers and to the students. And that's a way more fun role. Conversely, when the teaching staff is heavily involved in grading, you end up with this try to please the teacher feeling, and it can jeopardize the coach role that teachers play. And so one benefit of peer and self-assessment is that it makes clear that the major role of teachers is to be coaches. There's a bunch of other places that have used this stuff. And a couple of years ago, we had the opportunity to put these class materials online. And what I'm about to show is work that's been led by Chinmoy Kulkarni. So most of everything that I'm going to show for the next 10 or 15 minutes is stuff that he did in collaboration, some of it with Coursera. So what we did is we took a technique called calibrated peer assessment. And the savvy thing about calibrated peer assessment is when you get peers to assess each other's work, before they do that, you show them an example and you have them use that worked example where they'll grade it and receive feedback for how well they did. And then you have them go out and assess, in our case, 5 peers. And one of those, unbeknownst to raters, is a staff-graded submission. And that's going to give us a benchmark by which we can rate the quality of this peer assessment. This HCI course was the first massive online course to use peer assessment, and we designed the system with that class as the guinea pig. And I think it was kind of accidental in some ways that it ended up being the first class, but I think it worked really well because design is a field where the truth value of what we do is less crisp than 3 + 4 = 7, but it's easier to tease out excellence than it is in some other things. And so it was kind of an accidental but natural fit for this. And what we saw is that when we had students all over the world assess each other's work, on the whole, it works pretty well. So if you have a pass-fail class, having peer assessment grade the assignments works well enough to mostly get the right answer. But there are outliers. And if you're on the positive end of the outliers, that's great. But if you're on the negative end of the outliers, it can be really frustrating. And this is an email that a friend shared with me. It's from a friend of a friend. And I talked them into letting me share it anonymously. And as you can read on the screen, it's somebody who didn't get a certificate in a class that they worked really hard on. And their frustration was that, you know, I put all this time into it, you know, and it just turns out to be a bunch of students making things fit into a rubric, checking off a sheet, like talking about dog poop. What is this world coming to? It's an awesome rant. And I think that's right, is that there are clear failure modes of a system like this. It also turns out that doing design research that's being used in the world. So Chinmai's research has been used by more than 100 online classes, and so multiply that by all the students. And a lot of people have seen the work that he's done as a mid-career PhD student. And it turned out to have an ancillary benefit also, which is that when he went to get his visa renewed, his visa officer had taken a bunch of Coursera classes. And so they talked shop about his own research, and his visa went through. Though there are outliers that are negative, and we're going to get back to how we might improve that in a moment, the overall learning experience of students is a really positive one. When we ask people about what you like this about the class, what you like about the other thing about the class, you see a huge positive skew, especially in terms of how much did I learn doing peer assessment. Students learn a lot from this. And we can improve the numeric scores. Chris Peach and colleague developed a technique for more intelligently reweighting what raters to pay more or less attention to, or more specifically, shifting a bias for people who tend to run hot versus cold. And that can give you a much higher quality outcome as well. A simple thing, which to my knowledge hadn't been tried before, but it's pretty obvious and it makes a big difference, is that you can give raters feedback about how well they're doing. And so if we tell you that you know, you're grading high, you're grading low, that will influence your subsequent behavior, and you'll perform better after on. We've seen that this works across a number of different classes, but we've also found that for this to work well, you need to design the peer assessment intelligently. And so in classes that put a lot of time into rubric design and other things, you see a strong correlation between the staff-assigned grades and the peer-assigned grades. And when there's less of that, it becomes more of a mess. And that's one thing that we're going to look at in this talk, is how to get a stronger outcome. And but I really don't want to dwell on scores too much, because I think that one of the most interesting things you can do in a class like design is people are there to become better designers, to learn how to design stuff better. And so really one of the things that we should focus on is how we can scale improvement-oriented feedback, where I do some work, and I'd like to hear from somebody, what is it that I could do better? And feedback has a really interesting literature in terms of essay writing. That's where it's been studied most. And this is one of my favorite papers. My colleague Liz Losh sent these to me. And it points out that in this paper called An Anatomy of Awkwardness, it points out the challenge of the pervasive yet almost useless writing feedback, AWK, for awkward construction. And as Libby writes in her paper, you know, somebody calls it awkward, and even if you name it something more precise, the usefulness to the writer is minimal, because the injunction avoid awkwardness doesn't tell you what to do. And so really the feedback that is more effective is to give people here's what you can do better. And so my theory of effective feedback is roughly that it should work this way. Pretty good job, you know, pointing out that people have put a lot of time into this. Feedback that's exclusively negative is often demoralizing or discounted. And so pointing out the positive is really important. You can do better. We hold you to a high standard. We know that you can do this. And here's how. And so giving people a launch point for improving their work. And so to do this, what we did is we made these cued prompts. We nicknamed them fortune cookies because, like the fortune cookies that you get at a Chinese restaurant, they can be applied in a great variety of situations. And what these fortune cookies do is, anybody who's ever taught or TA'd a design class knows that the vast majority of projects, or really any class, have a similar set of failure modes or improvement opportunities. And so if you grade a bunch of these things, you can write down common errors, and this is true in a programming languages or compilers class just as it is in design. And if you give assessors these cued prompts for common errors, in the simplest version that we built, they're just on a web page, and you highlight them with your mouse and copy them and paste them. And we encourage people to add a because that customizes them. One benefit of cued prompts is that there's a classic time-honored HCI principle of recognition over recall. The reason that a graphical user interface is easier to pick up than a command line is that when you first use a command line, there's the cursor there blinking at you, and you have no idea what you can type. It's very difficult. You couldn't sort of innately know that CD is the way that you would change directory. On the other hand, with a graphical interface, everything that you can do is somewhere on the screen. And so the deal that the GUI makes with you is, I'll show you all the things you can do, click on the one that you want. And these cued prompts have a similar benefit. Click on the one that you want, and that works pretty well. You can leverage this. One thing that we realized from the crowdsourcing literature is that it can be difficult to have people do large tasks without much expertise. And for me, one of the most intellectually interesting parts about peer assessment, and one reason why people raise an eyebrow when they first hear about it, is you're asking novices to do something that definitionally you need to be an expert to do. And so that's interesting to me. And one thing that we've seen from crowdsourcing is many cases where well-designed structure can help novices do things that in some sense require expertise. And this is true everything from getting people to do protein folding at home to Michael's work on essay improvement. These are tasks that require expertise. And novices can do them if you give them structure. You're in essence making micro-experts for that particular task. And so in a paper that Chinmay, Michael, and I put together for the Learning at Scale conference this year, we tried out the idea of having student raters, instead of providing a score, they provide a label. And what you see with the label that they provide is we use these fortune cookies so that you're labeling submissions with features. And here we did it with text. And so students write short essay questions, short essay responses. And then the raters are going to label them with features. And you can see the feedback that they get from that is now, as opposed to getting a score, which is not super useful as feedback, you get back for your essay, you get these notes about these are the things that were correct or incorrect, the attributes of your response. And that makes it work a lot better. And this strategy that we've moved to is one of taking what used to be a large granularity task and breaking it down with more structure. And the literature has shown a number of cases in which this general strategy of breaking it down and adding structure can be really powerful. And so, starting with Tversky and Kahneman and friends, and more recently in social psychology, people have shown things that if you ask people, how long is it going to take to clean your house? People will really underestimate that. But if you say, write down all the steps involved in cleaning your house, now re-estimate, people are much more accurate. And Nicholas Kokalis and colleagues did this in their Task Genius system to help people get work done. And Michael had a similar strategy in his Soylent system where he broke down crowd work into a find, fix, verify pattern. And that yielded much better results. And that was the inspiration for our Learning at Scale paper here. And interestingly, I think an open question in this field is what we've done in the crowdsourcing case is we assign different people, or it's the same people, but they play different roles on different tasks to do the two steps. And there's been some recent work on what people call the crowd within, that you can get some of the benefits of the wisdom of the crowd by giving structure to an individual. The wisdom of the crowd is, as I'm sure many of you know, you ask 100 people to guess the weight of an ox or something like that, and because different raters have independent error, the average of those is of higher quality than any individual's response. And what my colleague at UCSD, Ed Vool, figured out is that if you ask people to guess for one of these crowd tasks, and then you say, well, assume your answer was wrong. Write down the reason that it might be wrong, and then make a new guess, on that assumption that it's true. Okay, do that again. And if you average those 3 guesses, you get a much higher quality result. And so in some cases, and I think this has important implications for learning, is you could have people self-assess by breaking it down and be able to scaffold their own learning and improve from there. And I think that's a really cool opportunity. So to summarize conceptually what we've seen so far, we have our insight that peer learning approaches work well when they're integrated, and that scaffolding is going to be our strategy for doing that. And I mean this in a pretty broad and fast and loose sense. There are a lot of ways that you can usefully add structure, but when done well, that's much better than just telling people, do the thing, which novices obviously can't do. And if we look at all of this stuff in aggregate, so all of the experiments that we've done in peer assessment, this teaches us 7 habits of doing peer assessment well. And if you're interested in trying this in your own class, this is something to look at. And so this recaps what we've seen so far, which is that it's important to have assignment-specific rubrics in training. That because we're having novices do an expert-like task, it's important to guide them in the specifics of that assignment. You can't have a general proof rubric and hope it'll work. It needs to be the proof rubric for De Morgan's laws or whatever it is that you're teaching. As with nearly any complex thing, iteration is extremely valuable. What's good for the goose is good for the gander. So the design methods that we teach are really important for the methods that we use in our creating our class materials. It's really important to have students assess themselves after peers, and I think that's because there's a mindset when you're doing the work that is different than the mindset of assessing the work. When, as authors, we write a conference paper and submit it, we're thrilled by our genius and can't wait to hear how our colleagues are wowed by that also. Of course, when you receive a paper as a reviewer, you look at it and wonder, why are all these flaws in here? And there's an asymmetry between how we value our own work at submission time and how we review our peers in the review process. And one way to minimize this gap is by having people self-assess their own work at the end. I teach a graduate class that's great research papers in HCI, and the students are really smart, and they will find flaws in all of these classic historical papers. And I love watching them rip into these great papers because I know that at the end of the quarter, we're going to review their work. And so you can just write down all the things that they demand of everybody else. And you say, okay, well, what if we use that for you too? And they say, well, in my case, you got to understand. But so we have different mindsets. And closing the loop with self-assessment really helps there. It's really important to gather ground truth data by staff assessing a random sample and putting those in the pool, and then plotting how well they compare, because otherwise you're flying blind. And you can do a much better job by using Chris Peach's approach of aggregating grades adaptively. We saw how cued prompts offer better feedback, and that you can, by feeding back to the assessors how well that they did, you can do a much better job. All right. There's a number of opportunities. One of the things that Chinmay and Michael and I are working on currently is thinking about how we can give students early feedback. Often feedback comes at the end of a project. This is true in submitting a conference paper. It's true in the final exam of a class. And having that goalpost that you're trying to get to is really handy. but it's valuable to get some early feedback about how well you're doing. One kind of early feedback is you could use these same peer assessment techniques that we've talked about, but just have it be for a draft as opposed to a final. And Chinmay are doing that with Ed Hutchins for a class that he's teaching at UCSD this winter. Another thing that you could do is you could give feedback to students early in the quarter about how things are likely to shake out. And I've been thinking about this in terms of an early warning system for students who aren't doing so well. Informally, we call this the bozo detector. And I think people often don't think through where they're going to end up if they keep staying on the same path that they're on. And it's not useful for the students or for us to have somebody whose course performance is just a train wreck. They're better off putting that effort elsewhere. And so one thing that we've thought about doing, and Chinmay built a machine learning model that does a pretty good job, is you ask the question, can we identify bozos, that is, people whose performance is, let's say, in the bottom 20% of the class, early on, let's say at the end of the second week? And can we send them a note that just says, you know, our model thinks that if you keep going at this level, things are likely to turn out badly. You know, it's just a model. It's got error. Who knows? But either way, this is a handy time to think about things. And you might want to reflect on how much effort you're putting into the class and whether this is the, you know, you can either engage more or you may want to do something differently if you're really not interested in it. And I think this is an interesting direction because it's a little freaky. Somebody described it to me as being like how Target knows that you're pregnant before your spouse does, that the learning model is inferring something that's unsettling. And you know, I think this is interesting as a way to think about what kinds of feedback can we give to students, both algorithmically, and does it matter if there's error, and then also how can we loop peers in to give early feedback better. And to return to the design studio that we started at, we were inspired by the design studio because of the benefits of peer learning that it provided just by osmosis of being in the room. And one of the big worries that many people have about online learning is that we'll have people all around the globe who are alone on their laptop, and you lose all of that. You lose all of that bonhomie that you get in the studio. And one of the surprising things about teaching online has been there's a wonderful amount of diversity that we see in students, and I think a huge opportunity for learning advancement is thinking about how can we harness that diversity to make the in-class experience richer. One example from my own class is that we have students do need finding, where you go out and do observational work. An online class is a great opportunity for students who are physically restricted to their home because you can do all the stuff online. And so for the first time, I had students on the forums asking me, how do I do my need finding when my physical mobility means that I can't leave the house? Totally interesting, and it's really fun. You can say, okay, here's a bunch of things that you could do. Similarly, Chinmay and I have seen ways in which students from different parts of the world interpret design assignments really differently, and that's a really cool thing to see also. And so in collaboration with Scott Plouse at Wesleyan, we put together this talkabout system, which has students do small group chats online. And so students can sign up for a chat, and then they talk with people. And in Scott's class, the materials that he'd come up with were they talk about hot-button social issues like racism, sexism, homophobia, using the theoretical constructs that they'd learned in their social psychology class. And we've used this in 5 classes, and Chinmay and Julia have helped the deployment in these 5 classes. And what's really funny is that in the peer assessment work that I showed at the beginning, you saw an example how we put careful attention to designing all of the learning stuff in our design class, and it worked pretty well. And that classes that put less attention into it, it didn't go so well. So you know, you would think that we would have learned that lesson. It turns out we didn't. That in Scott's class, where they put a lot of great energy into designing the materials, it worked great. You know, there's students from all over the world doing this talkabout. They learned it was really great. But we somehow never got around to doing it for the HCI class. And so because I didn't actually integrate this into the class in a meaningful way. We just sort of bolted it on as an afterthought. We got very little participation. And that's why I'm showing this slide for the third time to remind me, if nobody else, is that, I mean, it's not rocket science, but it's easy to miss that if you're going to try this stuff, it needs to be part of the story. People really liked using talkabout. We got a bunch of great feedback on the forum. For the classes that did a good job, this data is from Scott's class. We saw lots of people doing it both online, and interestingly, because there are some countries like Iran where Google Hangouts are banned, we offered the opportunity to do these in person, and we had 1,000 people show up or more to show up in person as well, which was really cool. And they went for more than an hour, which is far longer than we asked them to. We saw people from more than 100 countries doing this. And the experience of having these kinds of conversations with people all around the world is really powerful. And one thing that we saw was what one student called a mini UN, where for their talkabout, they had this diverse experience, and that really helped what they found. Chinmai's data mined some of the student performance as correlated with use of talkabout, and there's a modest effect where more diverse groups in the talkabouts lead to modestly better performance on the final. We're still working on what are the right ways to quantify or measure the success of something like this. And there's another thing which I wanted to share with you, because I don't know what to do with it, is that in these online classes, there's huge variance in student engagement. One thing that is frustrating about the way that the popular media talks about online education is many of you have probably heard that the dropout rate in online classes is high. And in my view, that's completely a nonsensical question to ask or claim to make, because it's a lot like if Amazon made all of their books free to everybody one day, and you could download onto your reading device any book that you wanted. I mean, what I would do is I would download 100 books immediately, and I would never even getting around to open half of them. And there are some that I would open just out of curiosity, but with no intention of finishing. And probably what would happen is that I would have a glancing experience of more books, and I would finish modestly more books than in the world where you got to pay for them. And I think that's what we're seeing in the online world, where half of the students who sign up for these classes never even log in. And so I don't see that as at all similar to when we talk about dropout. We think of the student who's in it for the class, and then the midterm grade goes badly, and though they intended to use it for their major, things aren't going well, and they bail. But here it's a very different experience. And we see that on the positive side too. So on the low engagement side, you have the people who sign up but never do anything with it. On the high engagement side, you see the people who do all sorts of amazing stuff, like there's all this stuff that people share online. Here's one example. A student from my class collated every single book that I mentioned the entire course and put it on a web page. And you can click through and buy these books on Amazon. And they probably are getting a few pennies for doing this from each book that they buy, and that's great. But I think this is a really interesting example of kind of end-user remixing. And what do you do with this eventually? Should we try to keep this web page up there forever? Should the next class recreate it? How does that work? Or all of the cool insights that people have on Twitter. We've had a really lively conversation on Twitter of students empathizing with each other and showing their work and doing all sorts of cool stuff. And for alumni, we have a LinkedIn group which has a great set of questions about design, and I follow it really carefully. So people ask things like, what platform do you use for prototyping? And students will write in with all of the current software and physical prototyping strategies that they're using. Super useful stuff. In some cases, students even come up with structured learning materials that are much better than what the course provided. So here's a beautiful table that a student put together organizing different evaluation methods and their relative merits. And it summarizes sort of a rambling lecture that I give and I had none of the structure, and they just distilled the whole thing down to one slide. In some cases, the projects that students do go on and have real lives, and so many of them are class projects for the sake of learning, and that's great. In some cases, we see, this is Chandramuli's project, and he wrote me that it's now being used in thousands of schools in 47 countries, and we said, that's great, would you like to be a community TA for the class? And so he's been involved since then also. And I really like the citizen science that happens as well. There's a Facebook group that for a long time I didn't know about, and they ran a poll of one worry we have about peer assessment is that it just takes too long, and we've been working on increasing the efficiency there. One of the students in an early version saw this too, so they polled their friends and they said, hey, how long are you spending on this? And they're doing their own measurements on the class, which I think is really cool. If you're interested in any of this stuff, we have a bunch of analysis code and software tools that Chinmay has put together online, and you can grab any of that stuff. It's all BSD open source. What I think a lot of this work raises is there's an interesting tension that on one hand, we've been working really hard to try and convey the underlying structure and principles of design. And valuable goal. I think it should worry maybe everyone that is this adding structure in a way that's nonsensical? Are we trying to claim that there are rules or principles that just aren't really there? There's a quote attributed to Ansel Adams that there's no rules of composition in photography. There's only good photographs. And for me, this is a really interesting quote because if you know Ansel Adams' work, he actually wrote the book on the rules of composition in photography. In fact, he wrote not just one book, he wrote 3 books on the rules of composition in printmaking and other techniques in photography. And so you can figure either dude is nuts or he's trying to tell us something. You know, I'm a glasses half full kind of person, and so I think he's trying to tell us that there are rules of composition in photography, but the ultimate crucible of success is whether something works as a photograph. And so the enterprise of coming up with these rules of composition is super useful. It moves the field forward, it makes better photographers, it teaches us something fundamental about photography, but we shouldn't lose sight of the fact that the ultimate success is whether the photograph as a whole really works. Another worry that many of you may have is that if we offer this structure and examples as a way of anchoring student work, we may end up with things cookie cutter. So if you put a bunch of materials online with structure, you'll end up with just cookie cutter designs, and we'll beat out all of the innovation. And here's a study that supports that Steve Smith and colleagues at Texas did this study where they asked people to make a creative alien, and they either gave them a prime that had systematically consistent structure of antenna, 4 legs, and a tail, or not. So either you see all of these as examples, and the question is, do you infer that things must be that way? And indeed, they found that showing the examples increased conformity. And so you might worry that, well, maybe nothing new is ever going to get created. What's interesting about this is that it had no negative impact on novelty. And so I like this study that Marsh did because it runs exactly the same study. And the only difference is it changes the dependent variable. So as opposed to measuring, did you borrow something from somebody else, you change the question to be, how much cool stuff did you do, how much novel stuff did you do on your own? And if borrowing from other people means that I do less novel stuff on my own, that's bad. But that's not what happened, is that in essence, people borrowed when they didn't have their own ideas, and where they did have their own ideas, they still came up with them. And what that shows is that these examples in this structure can help bootstrap people to get to a better place quickly, and they can still do their own creative work. Another worry that you may have is that this strategy of working from examples is just for small innovations. And here's a quote I think that Terry sent me from, or no, Jeff Hare sent it to me from Edgar Dijkstra. And Dijkstra says, look, you know, yep, using analogies, we link the new to the old, the novel to the familiar, and when things are moving along slowly, this is just fine. But when there's a sharp discontinuity, this breaks down. We can't leverage our past experience anymore. The analogies become shallow, and the metaphors become misleading. And this is the situation for radical novelty. And in Dijkstra's view, the computer science was a field that was permanently in a state of radical novelty. We are so smart and creative that we're always completely inventing the future. And consequently, we can't leverage any of the systems and structure and examples from prior work because it will just lead us astray. You won't be surprised that I'm going to try to refute this with an example. And so this is a painting by Picasso, Les Demoiselles d'Avignon. His biographer, John Richardson, calls this the most written about painting of the entire 20th century. And one reason for that, it was really instrumental in the creation of cubism as a strategy for modern art. And you may wonder where Picasso got these ideas. And he painted this in 1907, and he made hundreds of sketches in advance of the final work. And as part of it, that spring, his buddies brought him to the Trocadero, which at the time was the Ethnographic Museum of Paris. And in there, Picasso saw these Fang sculptures, which had just arrived. And Picasso was extremely taken with them. He was so taken with them that one of his buddies came back later with a trench coat and took one of them. And so if you look at Picasso's studio after this visit, you can see in the background on the shelf on the wall is one of these sculptures. And so at the time that Picasso was painting this, he was riffing off these ideas which were novel in European art, but were well known elsewhere. And Picasso's creativity here was that he figured out how to translate that insight into a new medium and use it in a new way. And I think this is why Picasso said that good artists borrow, great artists steal. Which you can take both optimistically. I think it's a great license that we shouldn't be afraid of borrowing, but you can also take it cynically. Picasso, at the time that he wrote this, credited the insight. And later, after the Spanish Civil War, but when he became director of the Prado, he rewrote history to claim that the insight for all of this was these old Iberian sculptures. And so this was really, Spain for Spain is where all of his work came from. And so he kind of put the attribution under the rug decades later. My postdoc, Stephen Dow, and I got interested in how we might be able to induce a process shift to get people to do more creative work. And as Michael mentioned at the beginning, one of the hardest parts about studying creative work empirically is coming up with something that you can measure. And the first thing that we hit on was really fun, is we had people come up with egg drop devices. And many of you may have done this in like a high school science project or something like that. And if you hadn't, here's an example of what this looks like. So you come up with this thing which has a parachute. We're going to throw it out the window. And when we look under it, the egg has survived. Incidentally, this particular device was built by a product design master student at Stanford. And our anecdotal experience is that the best people at making these were the product designers in mechanical engineering. And of all the people we tested, the worst people at making these were the people on the theoretical side of mechanical engineering, which is kind of funny. But rather than fomenting disciplinary battles, I think the more interesting part of it was, we found that some people came up with good ones and some people came up with bad ones, and that's all well and good. And but when we asked people about what they did and why afterwards, and I'm going to plug in the audio, and let's make sure this is working. Look at that. We found that people picked one idea early and really stuck with it.
On that, no, I don't know. For some reason, this seems to be the only idea. And there needs to be a platform, and then as good a cushion as possible with the materials. I don't see any other way.
I'm not a very good outside-the-box thinker, so I kind of just had one idea, and I was going to try and make it work.
I kind of went with the whole parachute idea and what I had from the beginning. So
this is the best approach for such a design.
And I love these videos because we've all been there, that the experience of doing design work, and in the moment you think that the idea that I've got is not just the best idea, but the only route that anybody could possibly go, is an example of what the psychologist Carl Dunker called functional fixation. In the 40s, he ran a ton of studies looking at enabling and impeding people coming up with ideas. And he asked these questions like, how would you affix a candle to the wall such that none of the wax drips on the table? About 20% of people have figured this out. You may have seen this before. The answer is you use the box that holds the tacks to do that. If you give people exactly the same prime, only where the tacks aren't in the box, then it's extremely easy, and nearly everybody figures out that you use the box as a resource. And so whether or not you see the box as a resource is completely a function of whether there's tacks in there. Somehow the tacks being in there, you don't see it as available anymore. So we wondered, could the design process offer a fixation anecdote? And the other thing that we're going to do, in part because my colleagues started wondering why I kept throwing eggs out the window, is we're going to move to web-scale experiments as a research platform. And what we realized was that graphical web ads not only make big internet companies lots of money, they're an amazing platform for being able to do in-the-wild experimental work. And so we ran a bunch of studies, of which this is one, where we asked people to do, in this case, design an ad where we'll either, in the serial iteration condition, give you feedback after each one, or in the parallel prototyping condition, you'll make a couple, give you feedback on the bunch, then you make some more. We held the time available for all of these constant across conditions, because whenever I go talk to industry and I say, hey, I have a better idea for how you should design stuff, they say, well, Scott, you're a very nice academic and a friend of ours and all, but you don't understand how the real world works, that in the real world we have time constraints, and so we can't do the cool thing that you think we ought to do. And so for all of these, we kept the novel strategy that we're trying time consistent with the existing strategy. And what we saw is people came up with all sorts of stuff. There's good ones and bad ones and creative ones and boring ones and all of that. And remarkably, people who employed the parallel approach, when we rolled their ads out on the web, they yielded more clicks than those in the serial approach. And even more dramatically, those click-throughs spent 2.5 times as long on the site. So we were not only getting more people, but we were getting the right people as measured by how much they spent on the site. And when we had experts rate them, because you might worry that the hoi polloi click, but they're in a design sense no good, that the experts rated them more highly, those in the parallel than in the serial condition, and they rated the designs to be more diverse. And I think a reason for this is that the comparison that implicitly is provided by parallel prototyping facilitates learning. And Dedrick Gettner and colleagues have done a number of studies on the power of analogy and analogical transfer. And here's one of those studies that I wanted to share with you. So she looked at the business school case-based approach of take a case, discuss it, take a case, discuss it. And she compared it with a comparison cases approach, where you look at two and then discuss the similarities and differences. And then what you're going to do is we're going to give you a novel problem, and you're going to apply those solutions, and we're going to see how much transfer you get. And what you see is that there's a 3-fold increase in the amount of transfer in the parallel case than in the serial case. And I think that's one of the reasons why the parallel prototyping approach works. And this comparison process becomes even more valuable for groups. So when we had dyads do this same task, and we had them either share one design or share multiple designs, we saw a huge and dramatic impact of sharing multiple designs over just sharing the best one or one that they had come up with. And that, as in the individual case, there are multiple different measures by which you see benefits of sharing multiple. So people explore more, they borrow from each other's features more, the conversations are richer, people achieve better consensus at the end, and there's a big increase in group rapport. And I think these group benefits of sharing multiple are important. When I talked with the design consultant Karen Holtzblatt about the process interventions that we were doing, what she said to me is that in many of the groups that she's worked with, they come up with lots of ideas, and she was less worried about the quality of ideas that somebody came up with and far more worried about, did the group actually use the good ideas that people came up with? And by having this increase in group rapport and consensus and better conversations, my belief is that we'll see groups adopt better designs ultimately. And this is some of what Bob Sutton found when he studied brainstorming. There's a large literature on, does brainstorming yield better ideas than other things that you might do? And so there's a bunch of studies where you have somebody try one brainstorming process versus something that would be not brainstorming, and you see whether they have better ideas or not. And the results are pretty equivocal. By that yardstick, it's hard to argue that brainstorming is a win. And what Bob figured out is that many of the benefits of brainstorming are social in nature, rather than just that it helps you come up with better ideas. And in particular, brainstorming really helps people achieve, it makes visible who the creative individuals are in an organization, and so you can acquire social capital by being creative. And it helps disseminate knowledge. So when Stu and I brainstorm about something, not only does Stu have good ideas, but at the end of the brainstorm, I now have learned things from Stu that I can use on my own later. And furthermore, it's really fun to do brainstorming. And so it's design processes that are fun are ones that people are more likely to participate in. And so people like it better and do it more. So what have we seen? Well, in these examples today of some of the research from my group and elsewhere, I hope to have conveyed that doing this kind of work where you get to make new stuff and then find out what people do with it is really fun. And also that in the modern world, it's possible to run real controlled experiments at scale with real people doing real tasks. And that theory can be really helpful here it's a useful design guide and one that's often undervalued. That, as a colleague of mine says, a year in the lab can save you an hour in the library. And if that sounds backward, I think that's the point. And so, we're not just taking theory off the shelf and use it, we're also learning stuff. And so my exhortation to close today is to encourage us to design in Pasteur's quadrant. Don Stokes wrote a great book that I recommend that Terry originally lent to me and that I bought 2 copies of since because I lent it out to lots of people. And the insight that Don Stokes had in writing this book is, let's look at research. We often talk about basic research versus applied research, but Stokes had the idea, well, let's make it 2-dimensional. And if you're in the business of theory building, a generally good strategy is to find something that people talk about as 1-dimensional and add a 2nd dimension. This is a harder sell when you're going from the 12th to the 13th for obvious reasons. But going from 1 to 2, people can grok. And so here we see the 2 dimensions that Stokes sets up are, is the goal of the endeavor to achieve some kind of fundamental understanding or not? And so an example of something that is seeking fundamental understanding but is not worried about any relevance to practice would be Stokes picks the physicist Niels Bohr as somebody who wants to build theory and just doesn't care about its relevance that much. And then conversely, you have somebody in Stokes' telling, like Edison, who doesn't care about the theory at all, but wants to build practical stuff. And then in the top right here, we have somebody who's inspired by use, that's trying to solve real-world problems, and sees as a strategy for doing that the ability to achieve a fundamental understanding. And for him, Pasteur is a canonical example of somebody whose vaccine insights were building fundamental theory and also making really valuable contributions in the world. And when I think about what we can do in the coming decades in terms of design as a field, I see this as a tremendous opportunity. Thank you very much. Here, we have a few minutes for questions. Martha.
Sometimes a decision can be a creative task.
I agree wholeheartedly.
Creativity. Can you talk a little bit about how some of these principles, thinking about creativity, could be, applied to decision making?
Yeah, so here when I've talked about design, it's been making stuff that looks pretty standard from a design perspective, graphical things or physical things. But I really think that most of white-collar knowledge work these days is creative work. And when people talk about the creative class, they include knowledge work in that framing. And so I think there's a huge opportunity for looking at a lot of the stuff that we teach in our design classes, like storyboarding. I taught in my design class last Tuesday. And then I was thinking about, I was in a faculty planning meeting, and you realize, of course, that storyboarding is a great way to elicit, visioning for future ideas that are anchored by real outcome goals, as opposed to just randomly coming up with ideas. And so I think that there's a huge and easy transfer pipeline to take all the design methods that we use, especially rapid prototyping, and just port that into knowledge work. I definitely am of the cult that all of life is design, and so our methods can be used for everything that we do.
So you had a very interesting slide on how to give feedback. Pretty good job, we can do better, and here how. So how can we work in the peer assessment case? This how part seems like difficult to achieve. How can my peers give me the feedback on how to achieve what I haven't been able to achieve, given their experience or lack of experience, and given the individuality of the feedback.
Yeah, so I think you're exactly right that the paradox of peer assessment is that you're putting novices in the expert seat, and that's one reason that people are leery of it. It's like if you walk out of the airplane and you say, okay, we're going to take Scott from 8B. He's going to be flying the plane today. People would rightfully be pretty nervous. And I just saw Almodovar's new movie, I'm So Excited, which the whole movie takes place in an airplane flight, which is a beautiful conceit. It's a really fun movie. You maybe wouldn't want them flying your plane. And I think what we see is that the number of failure cases is usually, the number of common failure cases is small. And so if you think about almost any activity, you can write down, if things go south this way, here's probably what went wrong and how to correct it. And so you can think about, if golf or tennis or any other ball goes off in the direction, if you see it not go if it hooks to the left, well, that's probably because you did this, and the way that you would fix it is you drop your elbow or do something else. And so because the failure cases can be grouped, and people, what is true is that it tends to be easy to recognize the outcome even when you can't recognize the cause. And so, you hit the golf ball and it goes off to the left. We can all agree, yep, it went off to the left. And the question is, well, how do I make it not do that? And what a coach will do is they will see what you're doing wrong and they can correct it. And of course, a good coach will have access to far more heuristics for realigning it than a novice will. But my thesis is that the beginning of that list of heuristics actually covers a lot of cases and can help a lot of people. And so some of the benefits that you often hear about with tutoring, Harold Bloom famously got a giant benefits of one-on-one tutoring. I think that we can capture a good chunk of that by carefully writing down what are the most common things that a tutor would say in this situation, and that novices can pick from among those, even if they can't generate them.
Are there strategies that you can really implement this tutoring thing online? Can you assign maybe assigners to students? Maybe they can follow throughout the class, and then maybe learn their typical mistakes. Maybe that might be different from the other students.
Absolutely. So I think that you can do many of these things online, and Chinmay's recent work has been looking at more iterative feedback, which for me is powerful because I very much share Salman Khan's view that the greatest educational transformation that we could make is to focus more on mastery learning. that the cadence of university life means that we move on whether you've learned it or not. And that means that we have a lot of people who never acquired fundamental skills. And this is crippling down the line, but too bad the river has moved on. And I think that but fixing that is difficult in the university context. And radical solutions probably are the right way to go. But I think we can make good progress within the framework that we have by having more incremental feedback, and that peers can play a really valuable role there.
How tight can you make the feedback loop in terms of like latency in like an online setting? Like, are there like practical concerns like on like reasons you can't have like instant feedback?
Well, I think that two of the muses, I mean, there are kind of, if you wanted to reverse engineer my research strategy, you can encapsulate it as this: be really inspired by how awesome design is and what designers do. Then think about, then steal ideas from social science and also ideas from crowdsourcing in order to build novel systems. And so a bunch of the work that Michael and others have done on things like crowds in 2 seconds are design patterns for doing crowd work generally. And I think they could really well apply in a lot of learning contexts. And I think that, I think the opportunity for doing synchronous or semi-synchronous peer learning online is huge. And my hope is that 20 years from now, it's just normal. It's just part of how life is. And I believe that can happen. Yeah, Michael.
So I've been turning this over and over in my head. I'm wondering what kind of effect peer assessment is having on the mental models of the people who are doing the assessment. This happens in crowdsourcing as well, but by structuring the process, I wonder if we are focusing people on sort of the syntax of doing design well rather than semantics. Like, are we building some sort of like Chinese room of design where people think they get it, but maybe they're not?
Yeah, I don't know how to map that analogy exactly, but I think the simple thing to say is it's absolutely the case that when you change the structure, you change what people attend to. There's the old maxim that which gets measured gets done. And so it's totally the case that if you change the structure, you change the thing. And one thing that I have worried about with that is I do think that the university system, both on land and online, encourages people to attend to score, which is just not super useful. And the act of scoring things, I think, brings that into focus more. And so pedagogically, one of the reasons that we've switched to doing more labeling as opposed to scoring is that the activity of label providing is probably useful as a learning aid in a way that score providing is probably less so. And so I think that's an example of a frame intervention. And we should, one thing that I want to spend more time doing is measuring how, depending on how we set up the structure, what it is that people pay attention to or remember down the road. Can we set up these interactive learning systems where the thing that you remember 3 months later, 6 months later, 2 years later is the most important thing? Let's do Jesse and then Stu.
So one of the things that question actually made me think of is how much like internalizing the process versus kind of deeply understanding something matters. So in math, for example, you can internalize the process for doing an integral. You maybe don't understand what's really happening. You just follow the specific rules. You just kind of get like, well, how do you think that translates to the design side of things?
Yeah, I think that's a good one. And my hope is that, my belief is that by making the structure explicit, people will increase the transfer. And I think that a lot of Dedrick Gentner's work and similar would support that belief that if you find ways to get people to focus on the deep structure, their ability to transfer increases. And that derives from a real riddle in the study of analogical thinking, that if you have analogy seems to be a fundamental operating primitive for cognition, that we reason by example. And what's paradoxical given that is that people are really crummy often at translating knowledge to new situations. And so the famous example is you tell medical students about a general who attacks a town and does so from 2 different directions so that people aren't aware of how large the army is. And then you ask, so if you had a patient where you need to zap them with with x-rays to kill the tumor, how would you do that? And people say, I don't know. And of course the answer is you go from 2 directions to minimize the impact minimize the collateral impact on good tissue. And so I think that some of this making structure explicit, or what Dedry's done, which is that if you can't generate the rubric ahead of time for whatever reason, you can ask people to do comparisons. And when we talked recently, she's been doing a lot of work on comparisons of very similar situations, which I think of as like analogical Pilates, that by focusing on a very particular thing, you can build up very particular analogical muscles.
Well, I essentially have a variant of the same question. I think there's literature that shows that when you learn a procedural skill, like calculus, you have to learn it twice. So you learn the facts about it in the scaffolding, as it were, and then you have to learn it again as a procedure to know how to actually do it. So it seems like that's amenable to your framework.
Yeah, I do think that many disciplines have shop skills and conceptual skills that go together. And the class that Michael and I are teaching, we have a lab day where we teach people the brass tacks of building designs, which includes things like typing commands into the terminal prompt and checking things in and out of source control, and other stuff that's not designed per se. But you'll stumble over those brass tacks when you're to do it in the real world. And so I definitely agree that you want to teach the shop skills and the conceptual skills in parallel, and that they're mutually reinforcing. If you can make the shop stuff invisible so you don't have to pay attention to using the drill press or the terminal window, then you can focus on the conceptual stuff.
One last question?
Right now in the peer evaluations, it feels like the majority rules. Like if most students are Americans, then people from other parts of the world, they're forced to design in the way that those American students like it. And this is like reducing the diversity in the design. What do you think?
We've looked, Chinmay actually one day started looking at the data and saw some evidence for what we call it a patriotism bias, which may or may not be quite right, that in some classes, and it's not entirely consistent, we have seen greater agreement among, students rate submissions from the same country as them slightly higher, even though they don't know explicitly what country it's from. Some of this, I'm sure, is markers, like if you talk about the Moscow subway station, you can guess where it's from. And some of this is relevance of the design to your local context, where the New Zealander comes up with a beautiful bike lane finding app, and the student from Beijing wonders why you would ever need such a thing. So we've seen some of that, and I think the answer is to figure out, the question again is how do you harness that diversity? One thing that I like about using Chris Peach's techniques is that if we get a wingnut rater, which, so if you get a wingnut, they get, in essence, counted less, and so you can have, you have to worry less about there being about somebody bringing you down unfairly. But I do think that there's a bunch of interesting ideas you can think about in terms of who should the peer cohort be for providing feedback on different designs. And my sense is that ultimately the long goal is that doing this globally provides other benefits in addition, and that we can have students learn other ways of seeing design. But if you buy the main thesis of this talk, then achieving that will probably require more scaffolding and structure of a sort. So, thank you.